Today's lesson is on outliers and their effect on the mean, the median, and the mode. So, consider this line plot that shows the average temperature in July in the town of Mathematica. So here we go. Here's the line plot, and each X represents the average temperature on a single day. So we can see that just by observation, there's one day that's really cold, the temperature is 7 degrees, and a couple days where the temperature is really hot, temperature is 26 degrees, and lots of days where it's in between those numbers. So it asks us, what is the extreme value on the line plot? Now, if you're only going to pick one, what's the extreme value? 7. Yeah. Because it's the one that's all the way by itself. And like you can definitely give me the argument that these ones are by themselves, and I would definitely accept that. But the thing is that they're only a couple away, right? They're pretty close. Whereas this one is significantly far away, right? So that is the extreme value on the line plot. Now, extreme value is the word that we've been using, which is fine, but it's not the mathematically correct term. The mathematically correct term is outlier. Okay? Outlier is the word that we use to describe an extreme value. So, an outlier is a value that is widely separated from the rest of the data and may affect the mean, median, and mode. So let's compare the mean, median, and mode in two scenarios. One with the outlier included, and another without the outlier. In other words, we'll eliminate the outlier, we'll determine the mean, median, and mode, so that way we can see what effect the outlier has on the mean, the median, and the mode. So let's find the mean, median, and mode of these temperatures. Okay? So here we go. July is 31 days, but I created this. I don't trust that I did 31. Did I do 31? 1, 2, 3, 5, 7, 8, 10, 14, 17, 19, 20, no, 25. So there's 25 days here. Okay, there's 25 pieces of data, and that's important because it will help us figure out the mean and also help us figure out the median. So, I can even write down below here. Mean, median, mode, and we're just going to say, I'm just going to say normal, and then without the outlier. So the mode is not going to change. The mode for this is 19. So even if we get rid of that outlier, the mode's 19. That won't change. Okay? There's 25 pieces of data. Which piece of data would be in the middle if it's in order from lowest to highest?
19.
How many? 19? It might be. Let's like half of 25 is 12 and a half, rounded up is 13. Do we end up at 19? Let's see. 1, 2, 3, 5, 7, 8, 10. Definitely. It's definitely 19. The median is definitely 19 if we look at it.
The largest number of data?
That's the mode.
Right.
Yeah, the median is the middle number. So that's why we took 25, the number of pieces of data, divided it by 2,
Right.
got 12 and a half, and then rounded it up to 13.
Okay.
So we look for the 13th piece of data in either direction. You can either start at the lowest and go towards the higher numbers, or you can start at the highest numbers and count back towards the lowest numbers.
Right.
Okay? So that's the median. Now, if we take away the outlier here. If we take away that outlier, and now there's only 24 pieces of data. And so if you take 24 and you divide it by 2, you get 12. But now you have to, because if there's an even number of data, we have to take the two middle numbers and add them up and divide by 2. So we're going to be looking at 24 divided by 2 is 12. So we're going to actually be looking for the 12th and 13th piece of data. So that would be, not including that first one, 1, 2, 4, 6, 7, 9. And again, we're going to get 12 and 13 both in here because that's 10, 11, 12, 13. So for the median without the outlier, we end up with 19, and we have to add 19 again, and we divide them by 2, and we end up with 19 anyway. So the median doesn't change either. So in this particular example, the median and the mode do not change at all if we take the outlier out. But what we still need to do is we still need to determine the mean, and then what the mean is with the outlier taken out. Now this is a little bit more work because what we have to do is we have to add all these numbers up together and then divide by 25. So if you want, you can, if you have a calculator, even if it's on your personal device, add the numbers up and see what you get when you add all the numbers up. So just add all the numbers up and see what you get. I'm going to kind of do it a little differently. I am right here that we have a 7. So I'm just going to write down 7. Here we have a 13, a 14, 2 15, so I'm going to write 30 down because there's 2 of them. 2 16, so that's 32. 1 17, 2 18s would be 36. 4 19s would be 76. 3 20s is 60. 2 21s is 42. A 22 is 22. 2 23s is 46. A 24 is 24. And 2 26s is 52. And then I'm just going to add all those numbers up together. So that's 20, 34, 64, 96, 113, 149, 225, 285, 327, 349, 395, 447, 471. That's what I get. 471 is what I got. Can someone verify that though? So now to find the mean under normal circumstances, we would take 471 and divide it by 25. And I believe you're going to get 18.84. 18.84. So I think you get when you divide those two numbers. And now if you take that 7 away, then both the numbers on top and bottom change. Now, it doesn't have to be trickier than you think it is, though, because you can just take 7 away from both of the. Well, no, you're not taking 7 away from this. This is going to become a 24. But you're going to take 7 away from the total. So what's 7 taken away from 471? 471 minus 7. 464. So it's just going to be 464 divided by 24. And I think it's 19.80, 16 off of that. So I think it's going to be 19.33333 repeated. How do I do? Cool. Okay, so there is a wee bit of a change in the mean. There was no change in the median, no change in the mode, but there was a change of roughly 0.5, half a degree in temperature by dropping the extreme value. Okay? By dropping the extreme value. All right? So that's what we see. And that's kind of the whole point of today's lesson is take an outlier and look at the effects it has on the mean, the median, and the mode. And in different situations, it may have different effects. In this situation, it had no effect on the median and no effect on the mode, but it did have an effect on the mean. The mean went down by about half a degree per day. So that's something you have to keep in mind, okay? All right. Is anyone still copying that down? All right. So here is an explanation of the effect of the outliers on each of the three measures of central tendency. If there are one or more outliers, they will have a strong effect on the mean. That's true. Outliers have a strong effect on the mean. We saw that. There is a definite difference in the mean by getting rid of the outlier. Okay? How about on the median? There is some effect on the median, but the median will remain relatively unchanged even if there's a few outliers. So there might be some change to the median, but there's not very much change to the median. How about the mode? Unless two or more outliers are the exact same value, the outliers will have no effect on the mode. Okay? So unless the outlier is the mode, there'll be no effect on the mode. Okay? It would be somewhat uncommon for your outlier to be the mode. So, because if your outlier is your outlier, and then it happens a whole bunch of times, then maybe it's not an outlier, right? Because the whole point of an outlier is it's kind of like something unusual. Okay, it's something unusual. So, hypothetically speaking, if Melanie scored 10, 9, 10, 9, 10 on all of her math quizzes, okay, and then she gets a 4. Well, obviously the 4 is the outlier, okay, and the 4 is that a real valid way of looking at what Melanie knows and what she doesn't know? Well, you could easily make the argument that it's not, because on each of the previous quizzes, she's demonstrated that she knows her stuff and then some, right? So that's the thing. But now, if she had like a couple of 4s, then again, we have to ask ourselves, is that even the outlier now? Okay. Example. Consider Gabe's quiz marks. Find his mean, median, mode quiz marks. And then it asks, is there an outlier? And what effect would it have? And then which measure of central tendency best suits his quiz marks? Okay, so let's do it. So now we don't have a nice little graphic organizer like a line plot here. We don't need it. But what we should do is we should write these numbers in order from lowest to highest. So there's a 0, there's a 7, there's 2 8s, there's 1, 2, 3, 4, 5, 6 9s, and there's 1, 2, 3, 4, 5 10s. Bless you. It's always a good idea to write the numbers in order from lowest to highest. It makes it super easy to figure out what the mode is, which number repeats the most, and It also makes it way easier to, way easier to identify what the middle number is. It doesn't necessarily make it any easier to figure out the mean, but that's okay. That's okay. So, start off with part A here. We'll leave the mean for a moment. We'll leave the median for a moment. What's the mode? 9. Very good. Yeah. There's 6 9s. 4. What's the median? It's also 9. Yeah. How do we know that? Well, there's 15 numbers here, and half of 15 is 7.5 or 8. So you're going to look for the 8th number, and the 8th number is this one right here, which happens to be a 9. So therefore, So therefore, that's the median. Now the mean, we get that by adding all the numbers up and dividing by the number of numbers. So, grab your calculator. That's 15, 23, 32, 41, 50, 77, 127. So it's 127 if you add all those numbers together. You divide by 15, and you get 8 point. I think. It's 8 point. Is it 8.42? No, what is that?
8.46.
Oh, 8.46. Okay, 8.47. It's 4666666, right? Okay, good. It's 8.4666. So it's 8.47. That's your mean. Okay? So that's your mean, median, and your mode. Quiz marks. Is there an outlier? Which one? 0. What effect would it have on the measures of central tendency? What's that? Well, would it have no effect on what? It would have no effect on what? The what? The median? No effect on the median? No effect on the... The mode? No effect on the mode either? But it would have an effect on the mean. Okay? So it would have no effect on median and mode. And I really shouldn't put this up here because I'm running out of space. I'm just going to say it does affect the mean strongly. Now that we are back on track, though, we look at part C. Which measure of central tendency do you think best suits Gabe's quiz marks? Do you think it's the mean? Do you think it's the median? Or do you think it's the mode? This is an opinion question, which means that there's not really a right answer here. But whatever answer you have, you kind of have to justify a little bit. So which one do you think would be better for Gabe?
The mode,
Okay.
because it's the most common score.
I like that answer a lot. The mode, because it's the most common score. If you look at any of the scores that Gabe received on the quiz, 9 was the most common. So if you looked at it as a sense of probability, there's a greater likelihood that he would get 9 on a quiz than any other mark. So I'm happy with that. Let's go with that. So we'll say that part C, the mode would best suit Gabe because it's the most common score. Okay. Can we remove the outliers? If outliers have a big impact on measures of central tendency, we will want to look at what they are without the outliers. We can simply remove the outliers. And because the mean is the only measure of central tendency that's heavily impacted by the outliers, we can calculate what we call the trimmed mean. The trimmed mean. When looking at Gabe's quiz marks, it's clear his marks range from 8 to 10 in all but one case. So a mark of 0 tells a story that is not quite true. He likely got a mark of 0 because he was away, and while we shouldn't just ignore outliers, we can determine measures of central tendency without them to indicate what a typical quiz score is for Gabe. Now, the next question talks about like gymnastics, and gymnastics is the same as like diving. Anybody in here watch the Olympics? Yeah? So when you watch the Olympics, I don't know if you've ever noticed it, but figure skating would be the same thing. When those sports go on, they always throw out the highest and the lowest score. And in some cases, they even throw out the highest 2 scores and the lowest 2 scores. That is to eliminate the outlier or the outliers and just kind of figure out a more reasonable way of calculating someone's score when they are diving, figure skating, or doing gymnastic stuff. Okay? So again, it's to kind of give a more accurate picture. And one of the reasons why that was done, I do believe, if my memory serves me correctly, I can't remember if it was, no, I think it was gymnastics, is back in the 1980s, when I was just a wee lad, the Russians were famous for their judges were giving uncharacteristically high scores for Russian gymnasts, and it was unfair. So again, the whole idea is to just make it more fair. So with that idea in mind, Jennifer receives the following 10 scores in her gymnastics routine, and I'm not going to read them out for you, but here they are. To find her final score, the highest and lowest scores are thrown out, and all other scores are added together to form a score of 60. Find her score out of 60. So first, we will throw out the highest and the lowest. Which one is the highest? 9.3. Great. What's the lowest? 8. Good. Perfect. So those are the scores we're throwing out. So there are 6 scores that remain, and we're going to add them together to get a score out of 60. Okay? So 8.9 plus 8.7 plus 9.0 plus 8.9 plus 9 plus 8.9. So we're going to add all those scores together. And again, we're just taking all those numbers and we are adding them together. But we're not using the highest or the lowest. And what do we get? Yes, Julian. It's 53.4. That's her score out of 60. Why do you think the top and the lowest scores are thrown out? Well, it just goes to what I was actually mentioning prior to the starting the question. It's just fairness and like just basically to avoid bias. If you have 8 judges, even if they're not from the same country, as the people that are participating. They may be biased towards a particular participant or athlete. So if you throw out the highest and the lowest score, you're just trying to make sure the scores are more fair. Last example, the trimmed mean. And we can define the trimmed mean a few different ways, but if we define the 10% trimmed mean, that's when we exclude or get rid of the lowest 5% and the highest 5% from a calculation. So the battery life in hours of a phone in standby is given below. So how many numbers are there here? There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5 times 8 is 40. So 5 times 8 is 40. So there's 40 numbers here. So if we are doing 10%, what's 10% of 40? What'd you say? 10% of 40. What do you think? Very good. Yeah. If you're not sure, just just so we know what percent means. Percent means out of 100. So take 10 out of 100 and multiply it by 40, and you're gonna get 4. So that means that we're going to be getting rid of 4 numbers. Okay, we're gonna get rid of 4 numbers. Now, half of those are on the high end, half of those are on the low end. So we're going to get rid of the 2 lowest numbers and the 2 highest numbers. So what are the 2 lowest numbers? I think I see the lowest. What's the lowest number? 28. I agree. How about the second lowest?
32.
I agree, because I don't think I saw anyone lower than that. No, I didn't. Okay, now let's look for the highest numbers. Highest is definitely 60 and
54.
very good. And especially if there's a big list of numbers, it's going to be really tough sometimes to navigate through the numbers to find the lowest or the highest numbers. So there we go. Now, excluding those 4 numbers, we're going to find the mean. Now, I understand. I look at this list of numbers. It's a big list of numbers, okay? So, all we're going to do is we're just going to add them together. So, if I was doing this, honestly, to make it easy, you could either do it I would either add up each row or column just to make it easier. So, I'm going to do maybe each row, because that's not so bad. So, 40 plus 42 plus 45 plus 37 plus 52 plus 48 plus 46 is 310. And then I'll add up the next row. So that's 75, 119, 161, 211, 269, 314, and 361. And if I get any of these wrong, let me know. Then we'll do the next row. 92, 141, 185, 227, 268, 314. Uh, 99, 140, 190, 241, 280. Okay. I'm gonna cheat on this one. See, they all start with 40, So I'm just going to ignore that for a second because I know that because there's 1, 2, 3, 4, 6, 7, 8. 8 times 4, 8 times 40 is 320. I'm just going to count the stuff above 40. So that's going to be 13, 19, 22, 24, 27. So it's going to be 347. Okay? Now, if I got any of these wrong, again, please let me know.
I think the second row is 351.
The second one is what? Sorry?
351.
351. Okay. Thank you. Good. Okay. So let's go ahead. 310 plus 351. Oopsies. 310 plus 351 plus 314 plus 280 plus 347. And that's equal to 1602. So we're going to take 1602, and we started with 40 numbers, but we got rid of 4 of them. If we got rid of 4, how many are left? How many? 36. Very good. So we're going to take 1602, we're going to divide it by 36, and we're going to get 44.5. That's the trimmed mean.